what's happening here. All right. Now I'm taking this triangle here. Let me take it. Let me go put it the other side so that you can see what's happening. The exterior, it's nothing.
Yeah.
I dealt with that. You know, with a normal triangle, they give you. You know, a normal triangle, the sum of the angles of a triangle add up to 180, don't they?
Yes.
Good. They can ask you to figure out that angle there. I'm putting it as theta. They say calculate that theta. You see that theta?
Yeah.
It means what you need to do. You must check the line. Yeah, get the lines that makes that angle. First, look at the lines that make that angle. It's actually this pink line. Can you see that? And also the yellow line. They make that angle. Okay, let me go that. Then you look for the x-axis, because those two lines, you draw them as I did, and then they must form a triangle. A triangle meaning the other side, it is your x-axis, which is this one here. Do you see that?
Yeah.
All right, so your triangle is what's inside here. It's this. It's everything like that's your triangle there. I just extended the line. So where now what you do to get that theta, uzosebenzisa inclination. How am I gonna get it? You must find the inclination of the yellow. You must find that one. Let's call it maybe alpha. So to get alpha, can you see it's gonna be obtuse angle? Can you see that?
Yeah.
So which means alpha is gonna be arctangent. Arctangent of the gradient. And remember, you must plus 180. Let's say maybe this number comes out. Let's say it comes out to be 100 degrees. Next, you want the inclination of the pink. Yeah, that line. Let's call it beta there. Do you see that angle is beta ne? Can you see its acute angle?
Yes.
So it's just simply arctangent. Arctangent of the gradient. Let's say it comes out to be maybe 40 degrees.
Yeah.
You don't have to worry whether the exterior. Where now what you do, because your triangle is this one here. What do you know about the sum of the angles of a triangle? They must add up to how much?
180.
What do you know about angle on a straight line? The one I'm doing it in orange. It's how much?
180.
Good. So that means you know what is this one, the one that I'm shading. It's 60, right? It's 80 now.
Yes, it's 80.
Just find the interior, it's 80. Now here you are able to do the calculation here. Can you see you've got 80, 40, and theta? So that means theta must be how much? 180 minus the 80 minus the 40. Am I right? Which is how much? Is it 60? Yeah.
Yes.
All right. If you don't work out this one, yeah, you wanna use this 100. You can just say the exterior. You don't have to do exterior. You can say 100 must be equals to the angles which are very far from it, not the 80. Which one are very far? The blue, the theta, and the 40 equals to theta plus the 40. Then when you bring the 40, that's 100 minus 40, still 60 degrees. Can you see that?
Yes.
That was that story about the exterior. It didn't have to be exterior. Once you've got the exterior, just work out the interior one, angle on a straight line, then you just do the sum, you're done. That's all it is. Yeah. particularly that angle which is far from the x-axis, far from the x-axis, far from the x-axis. Find the two lines which makes that line. Those two lines plus the x-axis will make a triangle. Then you do inclination angle for each of the lines. Then you can now do some of the angles of a triangle. That's the story you were asking. That's what appears in analytical geometry.